Alright, today we're going to be going over the integral of x to the 3 divided by 4 plus x to the 4. This integral was found in a practice for AP Calculus, so we're going to go over how you solve it and how you'd solve it on an exam. The first thing you want to do is when you see that you have this here, 4 is 1 bigger than 3, a u-substitution is probably going to help us cancel this out. So we're going to start with u is equal to 4 plus x to the 4. When we take the derivative, we get du is equal to 4x to the 3 dx. Already this is looking promising because we have an x to the 3 and an x to the 3. When we rearrange for dx, we get dx is equal to du divided by 4x to the 3. We can now plug in u. What we get is the integral of x to the 3 square root of u, and then du divided by 4x to the 3. Now these x to the 3's are going to cancel, and we're going to move our 4 to the outside. What we're left with is 1 over 4, the integral of the square root of u du. Now what we're going to do to make our square root a little easier to work with is we're just going to write it as u to the 1/2. This makes our inverse power rule much simpler, because now all we're going to do is add 1 and then multiply by the inverse. So what we're left with is 1 over 4, the integral of the inverse is going to be 2 over 3, and then not the integral, just that's our final answer, u to the 3 over 2, and then of course all plus c. To simplify this slightly more, this 2 and the 4 are going to cancel, and what we're left with is u to the 3 over 2 divided by 6, all plus c. Now before we're done here, we have to remember to substitute back in u. Remember we said u is 4 plus x to the 4. So our final answer is 4 plus x to the 4, all to the power of 3 over 2, divided by 6. And of course, you can't forget plus c. So there we have it. That's how you solve this integral on an exam.